So after chapter 2, we actually normally do chapter 7. And normally we would actually spend several days on it to do the whole chapter 7. But due to distance learning constraints, we're going to have to do just some highlights of chapter 7 in just one lesson, one day here. Um, so we're skipping some things that you actually don't need for AP Calculus. And so the main thing that we're skipping is something called matrices. So it's one matrix, multiple matrices. They're things that are used a lot in computer science and possibly in some college math courses. You might see them. But one of the uses for them that I do want to make sure that you see is a nice way to solve system of equations in your calculator. So 7.1, you'll have some problems on is just basic systems, solving by substitution, elimination. If anybody wants me to do some problems in a video, just send me an email and I'll be happy to do that. But hopefully you remember that. And so then in 7.3, we take a look at these 3 by 3 systems. So the general rule is when you had two variables, you needed two equations to solve it. And so now we've got three variables, three equations. So we call it a 3 by 3 system. 3 variables, 3 equations. And you probably remember these a little bit from Algebra 2. You probably didn't like them too much. Solving them by hand can take, read out a whole bunch of work, half a page, a whole page. Takes a long time, and like one little mistake, and the whole thing just falls apart, and it's pretty awful. Um, you might remember, like if you look at number 1, the idea would be like you could add the first two equations together, and the y's would cancel out, and so then you'd have one equation with just x and z, and then you could add the second and third equations together, and the y's would cancel it again. So you'd have another equation with just x and z, and so then you could just solve that 2 by 2, and it's a big old mess. It's doable, but it's a big old mess. It's a pain. So there's actually a way to solve these nicely and easily in your calculator using matrices. So because we're skipping all the matrix concepts, you're not going to maybe fully understand exactly what we're doing in here. But all you need to be able to do is type it in your calculator to get the answer for this system here. So what we do is we take kind of the left sides of the equations here, and we take all the coefficients from x, y, and z. So it was 1x, 4y, negative 2z. So we write down those coefficients there, 2x, 1y, 1z. Those coefficients go here. The coefficients of x, y, and z go right there. And then the right sides of the equation are in a separate matrix. So a matrix is almost just kind of like a table of numbers. It just holds a bunch of different numbers in there. And so you'll have to kind of take my word for it here that this system of equations is equivalent to this matrix equation, which you could look at as this is a matrix A, and then this matrix has our variables in it, so we'll call it the matrix X, and then this is our matrix B. And so what we want to do is we want to solve for the matrix X. We want to get this matrix by itself. So normally you'd probably think, well, if I want to get X by itself, you would divide A over. One small little detail, there's no division of matrices. Matrices, you can add matrices, subtract, you can multiply them, you can do everything except dividing. Well, it's actually not too big a problem. Think about a simpler equation. If we wanted to solve 5x equals 7, and I said, you absolutely must solve this equation for me. I'll give you $1 million if you can solve this equation, but you're not allowed to use division. You've got to find a way to solve this equation, but you can't use division. Well, you could still do it, right? You can multiply by the reciprocal. You can multiply by the fraction. If you thought that was cheating using a fraction because that involved division in there, well, you could say 1/5 is 0.2. You could use the decimal. Or you could say that 1/5 is 5 to the negative 1. The reciprocal is the negative 1 exponent. And so with matrices, there's something kind of similar to a reciprocal, something with a negative 1 power. It's actually called the inverse. And so what we do is, since we can't divide by A, what we do is we multiply by A to the negative 1. A inverse. And that serves the same purpose as division. It cancels out this A right here. And so then what we get is we get that the matrix X is A inverse times B. Well, again, you don't really need to understand that well, since we're skipping all the. Normally, we'd spend a few days on matrices. Since we're skipping that, um, probably don't see everything that's going on in there. Really, all you need to know is to solve a system using matrices is how to type the numbers in for the matrix. And just remember this: it's this first part, the left side coefficients has this -1 here, and then the right side numbers goes in this separate matrix here. And then we just need to know how to type that in our calculators. So if you press Alpha Zoom, you can get into a matrix menu. If you have a calculator that doesn't work, if you want me to show you the other way, just let me know and I can make a quick video for that. Just shoot me an email. But for most of us, Alpha Zoom will get us a nice matrix menu. And so to type this first matrix in here, we have 3 rows. Rows are across, so we have 3 going across, and then we also have 3 columns, 3 going down. So we're going to say 3 rows, and then we need to use the arrow buttons to move over and choose 3 right there. Hit enter. Move over that 3, hit enter, and then use the arrow to go down to OK. Hit enter again, and you'll get a nice 3x3 matrix there. And so then we just need to type in these numbers, which again, these numbers were the coefficients of the left sides of those equations. So you can type in the first number and then hit the right arrow, and then type the next number, hit the right arrow, type this number, right arrow, and then just keep going. Type all of these in here, type a number, hit the right arrow. Okay. So then now that we've typed in this matrix, we need to put this -1 here. There's a button just for it. If you look right below the math button, this X -1 is what you want. Push that X, the -1 button, and it will put that -1 there. So we say this inverse. So we're doing this matrix, the inverse of that. And then, I mean, you could put a times in here if you wanted, but of course, just being right next to something is multiplication. So we just need the next matrix right next to that. So you can do Alpha Zoom again. Okay. Now this one, so it's 1 column. Columns are down, and it's 3 rows. Rows are across. So we want to keep it 3 rows, and then move down to 1 column. Hit enter. Move down to OK. Hit enter. And just if you forgot which one was rows, which one was columns, just make sure that it looks right. Make sure it looks like this. If you did it wrong, it would just give you an error, and so go back and do it the right way. And so we'll have 0, hit the right arrow, 6, hit the right arrow, -13. Right, and so now we've got our matrices typed in. We can hit enter. And there is the solution to that system. Can you imagine having done that by hand? Can you imagine doing all that work and then getting these ugly answers out of it, having to plug them back in and doing all that? Well, it would have been awful, awful. Now, one thing is, I mean, rounded decimals are okay sometimes. If you want them as fractions, if you hit the math button, the first option there is a 2 fraction command. So again, this was the math button, and then this first option, if I hit enter, it will take my answer. That's what answer. Take my answer and then change it to a fraction. So those are our answers. So our answer matrix is 117 over 34 and -59 over 68 and -1 over 68. And so the first answer is the value for x, the middle answer is the value for y, and the last answer is the value for z. And that's it. Calculator did all the work for us. So if we want to try another one here, if we take a look at this one, so we're going to start with the first matrix again, Alpha Zoom. We want that 3 by 3 for the coefficients of the left sides, and then hit enter for OK. So we just want all these coefficients here. So 1, -3, 3, 2, 3, -1, 4, -3, and -1. And then remember, there's something that has to go next to this matrix. Do you remember what it is? It's the inverse, this A inverse. So push that x to the -1 button. And then we just put the other matrix for these numbers right here. So alpha zoom, 3 rows, 1 column, hit OK. And -4, 15, 19, and then hit enter. And there you go. So much quicker than all that work you had to do in Algebra 2, right? I bet you wish you knew how to do this in Algebra 2. Would have saved you a lot of time. But we wanted to make sure you could practice your algebra skills there. And that's it. Nice and simple. Easy answer. That's a 2 there. All right, so why don't you go ahead and practice this method on your own on this second problem right here. Notice there's something a little bit funny on this middle equation here. Hopefully we'll be able to handle that. One little thing, one little twist there. But go ahead and give number 2 a try. Try solving that problem in your calculator. And so there is that answer. Let's see if I can go back and show what it should have looked like in the calculator. So just a little twist right there is that if you've got a missing term, that you just have to put a plus 0y in there. The coefficient of y is 0, so you just put a 0 in there for the y term. So just make sure things are always in order. It's got to go x, y, z, right? X, y, z, x, y, z, x, y, z each time. All right, so that's one part of our highlights of Chapter 7. Now you know a nice, easy way to solve systems of equations in your calculator. The other highlight of Chapter 7 I want to show you is something called partial fraction decomposition. Okay, so before we actually do that, let's say that we have these two fractions and we want to simplify this, add them together. So we can't fraction bust because there's no equal sign. And so we have to make common denominators, right? We multiply by a funny looking 1. Multiplying by 1 doesn't change things. If it was an equation, I could multiply both sides by whatever I wanted. If it's not an equation, I can only multiply by 1. And let's say I messed up here. That should have been x minus 4. Okay, so we're making our common denominators. And so we've got 5x plus 10. And then we've got our common denominators, x minus 4, x plus 2. And then over here we've got negative x plus 4. And then that same common denominator, x minus 4, x plus 2. And so once we've got those common denominators, then we can add them together, combine those like terms, 4x plus 14. And if you wanted to multiply out the common denominator, you could, or we often just leave those factors. Okay, so hopefully you remember how to do that. We know how to put fractions together. Well, what does decomposition mean? Decomposition means breaking things down, right? Like there's dead bodies decomposing in the ground. All the part of the body is breaking down. So what we want to do is break down a fraction. We want to go backwards. We're going to kind of play Jeopardy today. It's like we're going to give you the answer, and we want you to figure out what was the question. Okay, and one of the reasons that we do this is actually very important in AP Calculus for some problems. There's something called an integral in AP Calculus. If you wanted to find the integral for this fraction here, as it is now, that would be almost impossible. It's extremely difficult. If you wanted to find the integral of this, as it was written originally, piece of cake, not a problem at all. So this is a technique that you will definitely use in AP Calculus. Okay, so we want to go backwards. We want to take the answer and figure out what the question was. So we want to figure out what were the two fractions to start with. Okay, well, we can see that if this was the common denominator, then these had to be the individual denominators. Okay, this was the common denominator, had to come from having those two right there. Okay, so what we would have to do is figure out what were the numerators. So we would just call them A and B. And then our goal would be to figure out, okay, what are A and B? Okay. Well, now we've got an equation. Well, an equation with fractions, we fraction bust. So we're going to multiply both sides by the common denominator. Whatever we do to one side, we can do to the other. All right, and so that'll bust our fractions here. The whole denominator is going to cancel out. So we're going to have 4x plus 14. Here the x minus 4s will cancel out. We'll have a times x plus 2. Here the x plus 2s will cancel out. We'll have b times x minus 4. Okay. Well, here's the thing. Right now, it looks like just one equation with 3 variables. We talked about, normally 3 variables, you need 3 equations. 2 variables, you need 2 equations. One equation, usually you'd only have one variable. So what the heck are we going to do with 3 variables, 1 equation? Well, here's the key. It's actually not just one equation. All right, remember, a and b are specific values. A and b are what we're trying to solve for. X could be anything. This statement here, when we said that these two fractions equal this one fraction, that's supposed to be true for pretty much all values of x. Okay, so this right here, there's infinite possibilities for x. So this actually isn't just one equation. This represents infinite possible equations for different values of x. So what we're going to do is for x, let's just pick a value. Pick a value for x and get pick a couple specific values for x and get a couple specific equations. Okay, so we're going to pick values for x. Now here's the thing: that the first thought that people usually have is, oh well, if I'm going to pick a value for x, why don't I pick 0 or 1? Because those are nice simple numbers for x. There's actually better choices that we can make for x. There's actually 2 particular numbers that are kind of staring us in the face that are really nice choices for x right here. Right? One of them would be 4. Take a look at what's going to happen if I plug in 4. If I plug in 4, this whole thing is just going to be 0. It's just going to be wiped out. So one value for x that I'm going to want to use is 4. So I'll have to replace all the x's with 4. So I'll have 16 plus 14 is a times 6. And then there's the key. This whole part over here is going to be 0. So I'm going to have 30 equals 6a. And so I can really easily find that a is 5. If I use like x was 0, x is 1, I mean, I could make it work, but then I'd have to solve a system. Be a pain. Much easier just to kind of wipe this part out. So I'm going to use x equals 4. Can you see what the other nice value of x that I'm going to use is? I used 4 to wipe this out. So what could I use to wipe this part out? Be -2. If I use x as -2, then this part is going to be 0. So we'll replace all the x's with -2. So we'll have -8 plus 14. This whole thing is going to get wiped out. This will be 0. A times 0 is 0. Anything times 0 is 0. And then over here, I'll have b times -6. So that'll be 6 equals -6b. So b equals -1. And then, of course, I'd have to actually go back and write my fractions. So I would have to say 5 over x minus 4 plus -1 over x plus 2. Take the a and b, put them back in these fractions that I wrote. And look at that. That's exactly what we'd started with. We were able to go backwards. We played Jeopardy. We started with the answer, and we went back, and we figured out what the question was. Okay. So there's one kind of funny thing going on here. So we said that this equation, this statement is supposed to be true for all values of x. There's actually a couple values of x where it's not really supposed to work. Because there's a couple values of x where these would be undefined, right? We're actually not supposed to have x equaling 4 or -2. 4 and -2 are the values of x that would make this be undefined, make these fractions be undefined. So we actually shouldn't really use x as 4 and -2, but they were so nice and they worked. So even though there's a little bit of kind of funny business going on, we do it anyway because it works. It's called like the Heaviside method for partial fraction decomposition. So Yeah, a little bit of funny business, but it works. Okay. All right, so let's try problem number 2 here. So we're doing a partial fraction decomposition. We're breaking down this fraction, also called a rational expression. And so we want to figure out what were the two fractions that we added together to get this one fraction. Okay. Well, the easier part was to figure out the denominators. We've got this common denominator, so we can figure out what the original denominators were. It's a little bit tougher to see on this one, though, because this one needs to be factored. If I factor the denominator, then I'll be able to see what the individual ones were. So we've got x and minus 3 and plus 2. So then if this is the common denominator, then that's what the individual denominators would have to be. I just need to figure out what these numerators are. Right? If you wanted to switch the order, it wouldn't matter, right? Just as long as at the end your A goes with which denominator and your B goes with which denominator. Of course, addition's commutative, so you could write your answer. You could flip-flop the fractions either way. Okay. So now we've got an equation with fractions. So we're going to fraction bust. So we're going to multiply by x minus 3 times x plus 2. Over here, the whole denominator is going to cancel out. And then just be careful on these. Sometimes when people go too fast, they think that the a is supposed to still go with the x minus 3. Remember, it's the x minus 3's that are canceling. So the a should be multiplied by the x plus 2. And then here the x plus 2's are canceling. So now the b needs to go with the x minus 3. It kind of switches. Okay. All right, so then this is supposed to be true for all values of x. We want to look for some particularly nice values of x. Hopefully you see a couple nice ones here. -2 is going to be a nice one again. We're looking for what's going to zero these things out here. So if I use -2, I'm going to have 5, and then this part's going to be gone. And then -2 minus 3 is -5. And I'm going to write it -5b, because that's how we're used to seeing it, right? B times -5, -5b. And so that's going to give me b equals -1. And so then my other x value, I zeroed out this one. Now I want to zero out that one. X minus 3, the value of x that makes that 0, is 3. So I plug that in. I've got 10 equals a times 5. A times 5 is 5a. And then this becomes 0, so it just goes poof, just disappears. If 10 equals 5a, then a equals 2. Okay? And so just don't forget to actually write the fractions, right? And so we know that a, which is 2, went with x minus 3. So I've got 2 over x minus 3. And then I've got -1 over x plus 2. Okay? So if that was the answer, then this was the question. Okay? Now, this one we don't already have, before on the one that we just done, well, we had this, staring at us that we knew, okay, those were the original fractions, so we knew we got it right. What about this one? Is there any way to know for sure that we got this right? Well, of course there is. We could just check it. We could try adding these together, right? If we add these together, I should get this fraction. If I do, then I know I got it right. So I could take this one and I could multiply by x plus 2 over x plus 2. Okay, I'm really only interested in the numerator, right? I mean, I know when I do this common denominators, I'm going to get that common denominator. What I'm interested in is the numerator going to work out? So here I would have 2x plus 4. And then over here, I'd be multiplying by x minus 3 over x minus 3. Really just interested in the numerator, though, so I'd have -x plus 3. So what do you think? Did we get it right? Does this look good? If I add these together, I've got x plus 7, which is exactly what I was supposed to have. So I know I got the right answer. I don't have to wait to hit submit on the Canvas quiz to see if it was right or not. I know for sure that I at least got the points for this problem. All right, why don't you go ahead and try number 3 on your own. Go ahead and try to find the partial fraction decomposition of this rational expression. So hopefully maybe some of you had already checked your answer on your own. Again, we talked about how to check the answer. It's such a quick, easy check that I do expect people to do that on tests. I don't give a ton of partial credit on this kind of problem or on any problem where it's such an easy, simple check. I'm usually expecting people to do those kind of checks. So hopefully some of you did that already and already knew that you got the right answer. But you can also check your answer right here.